How's it going, everyone? Olier Gonzalez here again, and today we are looking at the advanced Redux. What is a problem that Redux actually solve, as well as the goal of this course and this series of videos, and in today's video. So let's get started. The whole point of today's video is that we are now going to see what is the intrinsic values that each one of those functionality that Redux solve and provide. What are the convenience of users and what is the problems that they're using, and for that we need to know how do we get here, because once you understand that, you will embrace complexity. So what does it mean by that is just a brief recap of what is this Redux, okay, which is this course is taught by Steve Kinney, head fronting engineer and Temporal, where he now previously worked at several companies. One of them is like Twilio, right? So this advanced Redux, which is something that we are not going to dive into the fundamentals of Redux, what is the problem that Redux actually solve. We can only briefly describe that. And the reason why we get here is because when you want to develop applications, you have now the backend, the API, and the frontend. All right. So the idea is that as you develop the frontend applications, we have now a legacy or old way of doing things, which is lay out the foundations of how you're going to build these applications. So we have now this pattern called the MVC, right? The model view and controller. That client-side architecture works pretty well, but it was quite slow when it comes to provide now rich web app or full rich web app in interactions. So because a user in time you have to navigate to a particular document on some server, or in the case when you navigate to a URL, for example, you want to shop something, whether it's through Shopify or Amazon, or you want to just simple search for something, a lot of the time it needs to perform is a round trip, right? So back in the old days, they have to do this round trip. So that is something that takes time. The user sits here and wait for the content to be low. But recently is now a theme that, with the advancement of especially the way how you can have access to this content, because it's not only in a laptop like right now. A lot of the time you now get access through your mobile phone, okay? So because now the industry, especially in the information or any of the hardware computers actually move forward to now to orientate all of our daily activities through the mobile. Chances are that, and there is also a very interesting website that actually gives you that global GS count. I think it is exactly GS stat count. Okay, which is actually tells you is this is for entrepreneurs. You know, it's like for small mid business as a way to now have some sort of public data about that. So the thing here is that, as you can see, the dominance of the browser, right, as well as the market or the mobile tablet versus desktop, right? Now a lot of the time people actually use more mobile than desktop, even though I include myself in this statistic, especially when you shouldn't do that when you go to sleep, when you go to bed. But in any case, yeah, the mobile, desktop, and tablet. In here we can see is this particularly statistics and how now have decreased in the last year in favor of the mobile, right? So what does it mean is that I don't know if we are able to see this any chart, see that from 2009. Okay. Let me see, is this actually gonna load that properly? All right. It's a lot of data, of course. Yeah, it's a lot of data. Yeah, it's a lot of data. That's what happened. So desktop has fallen in favor as a very lovely graphic. In 2016 was the breaking point of that. Thanks to GS Count, this website, Stat Counter, Global Stat, for actually providing this kind of thing. So what does it mean is that now people see that using their mobile is much more compelling rather than the desktop, because now they can have access to this quickly. That's one of the reasons, at least from a personal views. And we need that this application load fast, right? I don't want to wait any time that I visit to a particular URL and therefore sits there pretty much like I was on my laptop. So no one's to do that. So I don't want to sit there. No one wants to sit there to actually listen or wait for that. So what happened is that the way how you now need to construct these applications have to change to satisfy now this market, to satisfy now is this convenience. Okay. So because of that change, which is quite interesting, in 2010 actually the trend started to change. React came here as an alternative to that, so we can say React found React birth year, right? React founded year 2013. React was founded in 2013. We're talking out here. We begin tracking tablets console as separate platform from August 2012. So, and tablets. Exactly. Again, tablet has not raised that because it's not quite convenient. And because now mobile has been part of an extension of ourselves, and it's way much more easy to carry on, to manipulate, and to interact with, and do stuff with it. We begin to tracking here. So you can see 2013, all right? The initial public release in React in May 2013. Let me actually ask Perplexity about this. Yeah, Perplexity. When was the year React became open source? Well, you get it right. In May 2013. Okay, but in May 2013, that was the year that it became open source. It makes a lot of sense. It makes a lot of sense. So because of that, that after all, React is great for building small user interface, okay, in a way that is declarative, in a way that you don't have to do this dumb manipulation, all of this imperative instruction that you have to tell, hey, DOM, I want you to now get this element, then I want you to is get this element and then query that as a way to now populate that with the proper content. Let's say you are now showing us a card to the user. With this card, you say, hey, this is the image of the Louis Vuitton, or the and as well as the name of the perfume, the type of the perfume, which is whether it is eau de parfum or perfume strong, the price, the description, blah blah blah. You know, you are now is creating this small user interface, this car, pretty much like a car presentation, okay, like a physical car, but you are doing that in the browser, okay. You're telling the browser how to do that. Hey, I want you to now is query this element, okay, and then going to populate here the image, and then write down here the title, the description, the price, you know. So you have to do that imperatively. You have to tell the computer, hey, this is what we want to do, all right? But React say, hey, good, but it's a lot of work to do that. So let's going to handle that for us and make it simple when it comes to create this small user interface, right? So instead of you doing that, let's going to now hold an state and a data that we're going to update that whenever we see fit. So whenever we fetch data from the user, from the server, for example, whenever the user interact with this data, hey, it click on the car to actually receive this Louis Vuitton perfume, okay? And I think it all start here, and I think now it all start here, and as time goes on, things are starting to become more and more and more complex, especially when you now have to deal not only small applications like this or user interface, all right, but now is giant e-commerce, okay, in all the different users case that we need to handle. We need to show notifications. We need to also provide is the way of how you can track the orders of the user, as well as at which state the user, at which state is the package being delivered. Also, the credit cards, you have to be sensitive with that data. You don't want to share it. You want to you want to encrypt that data. As well as hey, we want is to how do you put it, we want to also show the profile data, as well as their balance. So all of this different piece of information, we need to find a way to keep track of that in the application. And that may not sound very appealing or very so tracking things is something that it perhaps hits our own nature of being telling what to do, especially when you are an adolescent, when you're young. It's like, I don't want to tell me what to do. But again, the track here is something that happened because those companies that actually provide this service, they want to know what's going on. And imagine that you have now a very beautiful car, okay? Perhaps a Sierra or a Lambo, right? Whatever car it is, given your particular budget, you want to preserve that. You want to know what exactly happened to this. And also you want to know, for example, is what are you eating, how you can maintain your health, how you can look not only beautiful on the outside, but also how you can keep and maintain your own psychological health. So tracking things is something that it can be quite awkward to talk or some sort of it can produce some oh my god. Did I lose my mind? When you are compulsive, obsessed, when you obsessive compulsive with yeah, when you're obsessive compulsive of something, I don't know, obsessive compulsive disorder is like OCD. Sorry, that's right. Obsessive compulsive, right? Obsessive compulsive with doing this repetitive thing that you need to know, you need to do as a way to guarantee this kind of thing. But there is a trade-off, as anything, and also some benefit that. Again, this is exactly what React is doing, what React offers initially. And then they face some new challenge, which is, hey, how can we now make these things, well, manageable and maintainable, especially when you need to deal with all of this information. So Redux Redux, let me actually now, when was the year Redux comes out? Okay. In 2015, it was developed by Dan Abramov and Andrew Clark. Oh my god. Mm-hmm. Wait, what? Dan Abramov, okay, over React, a blog by Dan Abramov. Okay. The two Reacts. Okay, I changed reaction. The limit of my language means the limit of my word. Before you memo. Interesting. Exactly. So it was defined by Abramov, right? You know, and then started to have this particularly challenge here. And then we are, so not only that, right? Not only that Dan Abramov create this library, and there are also some people's like now they are maintaining that library. For example, Git Nation here. Yep. Like Mark Erickson, all right. And this is a very interesting talk when Mark Erickson actually describe a little bit of that. But the TLDR of all of this, right, is that this is a library okay, that is making now anytime you want to update your state from different sources, right? Make it predictable and know what's going on, and also be debuggable. Uh, so you can be debuggable, testable. Two more of my favorite things, and because when you because it was influenced by this flux architecture, okay. Um, for read about flux architecture. Because of this, okay. Mm-hmm. But because of this, right, flux has been achieved and further change will be made. So because of this architecture, okay, that is was used for building the Facebook used for building client-side web application. Again, all of these companies, top tech company, now are facing specific problems in that area. It's like how can they come up with some solution that of course creates more problems and that kind of thing. But the thing here is that because traditional ways favors an unidirectional data flow like MVC, so Flux application has three major parts: the dispatcher, the store, and the views, right? So this should not be confused with the model view controller. Controller do exist in Flux applications, but there are controller views, right? View often found at the top of the hierarchy that retrieve data from the store and pass down to its children. Additionally, actions creator, dispatching helpers are used to support a semantic API that describe all changes that are possible in the application. It can be useful to think of them as four part of the Flux update cycle. So Flux scheme MVC or Flux skews MVC in favor of unidirectional data flow. So that's the whole point about Redux. Is like, because when you create now this Redux or these React applications, a particularly pattern that has been shown in the industry is helpful is to pass down data one-way data flow, right? So from the root of that element to all of the children elements as it is. And there's some challenge to that, as like anything, all right? But the view, exactly. So when a user interacts with the React view, the view propagates an action through a central dispatcher to the various stores that holds the application data and business logic, which updates all the views that are affected. This works especially well with React declarative programming style, which allow to store and send updates without specifying how to transition view between states. Okay. We originally set up our deal correctly with derived data, for example, like this. On read count for meta threads, while another view show a list of threads with the unread one highlighted. This was difficult to handle with MVC. Marking a single thread as read will update the thread model, and then also need to update the unread count model. And this dependency and cascading update often occur in large MVC application, leading to tangled weave of data flow and unpredictable results. So the problem with that MVC model, or this older way of creating these applications, or this traditional way of creating applications, is now the way of how you can now update several data on the client to provide now a better and faster user experience to that, right? So this is now the structure of the data flux applications in a single direction. So you dispatch an action or you create an action, and this action is going to be dispatched by a reducer. That this reducer, what it does is to update or generate a new state to the store. So now the store, that is a centralized place that propagate those chains to any view that makes access to, right? So a unidirectional data flow is central to the flow pattern. And the diagram above shows the primary mental model for the flux programmer. The dispatcher stores and view are independently nodes with distinct inputs and outputs. The actions are simply object containers and new data, and they identify a type property. Because again, all of this come from this particular way of doing this, right? So actions creators are helper methods collected in a library that create an action from the method pattern assigned, which is something that Redux actually provides for us. So every action is sent to all the store via the callbacks, the store register with the dispatcher. So after the store updates themselves in response to an action, they emit the change event. So special view called controller view listen for changed events, retrieve the new data from the store, and provide the new data to the entire tree of the view of the child view. So because what happened here is with this flux architecture, just this convenient way of now we can solve is the problem of updating different data in our applications on all of this user interface. Okay, of course has come with some trade-off, okay, and some challenge that. So those challenges and trade-off, right? And I make all of this because as those challenges emerge and that kind of things, people started to use way more and more and more their mobile than their laptop, right? Because it's way much more convenient. It using now the desktop. I don't know if they're actually at a laptop, all right? That'll be great to identify that. And at least in the United States, okay, that trend has, of course, increased at the same pace. So with that, okay, so now that we know the story of how do we get here, now we understand is that, well, that's quite interesting. People drop the use of mobile in the last year in favor of a desktop. Okay, that's very, very interesting. Very, very, very interesting. Very, very, very interesting. What about Argentina? So because of that, Argentina prefer is mobile here rather than desktop. But in any case, so the idea of looking at this, let me actually do this. All right. So, but the idea of looking at this is just another resource here. Okay. What we're gonna talk about is the mobile market share, desktop mobile market share, yeah. So desktop, mobile, and tablet, market share, okay. So the whole point of doing this, all right, is to understand again how do we get here, all right, and why actually we are doing the thing that we need to do. And since this course is looking at the Redux RTK. So what is the problem that first Redux actually solved, which is provide a convenient way of how you can manage your state in your applications. That's one. And because this requires a lot of ceremony to actually set up something properly, and anytime you want to add a middleware to this state management or some sort of piece of software in between, you need to actually Google a lot of things to actually make that works, and not to mention that TypeScript was not well supported, so you have to go to arcane types to declare the intention of the code to others and to yourself. So this is now the challenge that Redux actually is one of the challenges that Redux actually here made us, right? Because it leads us with more sometimes questions than answers. So this course is, well, we're gonna look at what this well-battled test state management actually work, and with that, we're gonna see what are the particular problems that actually solve, which is something that I already mentioned, is that this ceremony of creating and setting everything from the scratch to actually start to manage your states. And the other is, well, I'm repeating myself quite a bit. I know for sure. Just to recap here, the other problem is that, well, adding middleware here is something that is requiring you to finding a lot of stuff out there on Google. And last but not least is there are no way to actually provide this, or there was a very hard time to actually integrate that with TypeScript, which is something that even though that it has its a particular way of working, setup, and that kind of thing. So TypeScript provides a business value, which is declared is the author intent about that code, which is useful not only in terms of readability, data flow, as well as detect errors at build time, not run times, and also this nice little auto completion features, which is, I think that's the most things that I like of TypeScript for the developer perspective. So here, so first we're gonna see is the Redux toolkits, and that is well, how to have an actions to work through reducers, and we're gonna see the intrinsic stuff that's going on behind the scenes, and then how we can use types. All right. He mentioned something about how to work with related models. And I'm gonna hit the brake here a little bit. So when we talk about models in this context, it's about data, how you can work with different, or how you can work with related data. All right. So for example, you have a user list or orders. So how you can use Redux as a way to work with this tool, as a way to work with these two models in a way that is much more easy to do that, right? There's something called extra reducer, which is, again, something that we're going to see along the lines. And another problem is that, well, type hooks, right? And last but not least is the asynchronous nature of this state management, and that is RTK query, right? Which now provides a way of how you can fetch data and update the state properly. There are other solutions out there. So for example, like Redux Saga, which this is effects is manager, all right, an intuitive Redux side effect manager. And you may wonder, what is this side effect manager? Let's go beyond the scope of this course and just briefly mention that anytime you need to run this side effects, and usually this is code that alter the program's primarily functions by mutating their global variables or the data structure, or by performing this input and output operation, which is our case. We're fetching data and sending back to the server. So once we do this, it is important to now understand what this is trying to solve, right? We looked at we can now use Redux and the problem that Redux solves, which is how we can maintain, how can we manage the state of our applications in client-side applications that allow us to provide is a fast, better user experience for mobiles, all right? Especially for any device that can have access, that have a browser and then can have access to web page, right? But the thing here is that it's much more convenient for those mobile users. I included myself, and I thought the same for the others, right? Which is, again, it's very compelling to do that. So what does it mean? This is like that. It's like now instead of actually looking at the state management, which is great, but when it comes to actually fetch data, which is another way of, this is another area, another component of the front end app or the front end system design, right? You have how you're going to communicate with the data, okay, which is the API communications, HTTP, WebSockets, server-side events, right? You also now is how you're gonna manage your data and your states, data management using its Redux, as well as how you can now is manage is user interactions, okay, for complex use cases, and the asset management. But when it comes to network operations, to perform these side effects, it's important to do that in a way that is predictable, all right? And that we get the data once we need them. So that's exactly what it's trying to solve here, Redux Saga. Is that when we're going to now fetch or when we need to perform these side effects, data fetching, we want to know and we want to have a way to do that in a maintainable way, right? That's quite interesting. And the using behind the scenes is a concept called now the how do you put it? Yeah, a concept called generators. First iterators and then generators. And I think that's quite interesting, my friend. Very, very interesting. Very, very interesting. So, okay. Good for all of this. That's right. And here we are, right? So first thing first is the Redux toolkit. Okay. So first things first is Redux toolkit. Okay. What in here we're gonna see is that, well, how everything starts here and why is the problem that a slice solve, all right, which is instead of actually us creating all of this ceremony, which is defining the type, defining the actions type. Remember, following is the architecture, the flux architecture, which is defining the type object of the actions as well as its payload. You're gonna define all the possible actions in one particular file. Then you're going to define in another file all of your reducers which means that this dispatcher or this function that you're gonna take the state and these actions to generate a new bit of a state. Okay, why we generate a new bit of a state? Because when we do that, we are now given the JavaScript nature of this mutability data. When you generate a new state, the industry and a lot of people out there has shown that this is a more convenient way to manage the state and to update the state, right? So instead of us mutating directly that reference, we're just going to update that reference with a new state. Okay, so how you can explain that? I would like to actually that. So instead of for the computer and also for humans to keep up the pace and to maintain that, generate a new bit of a state has shown that instead of actually, it all boils down is to how much it all boils down is that what will happen, okay, that everybody wants to access to the same resource and then try to modify each one of this, right? Especially what will happen that everyone wants to access to your motorcycle, okay, of all of your family, I don't know, perhaps your siblings and your cousins wants to get on the bike. This is a very common example, right? You got a new bike and everybody wants to actually jump in here. All right, so you can let everybody be on this at the same time of the bike, right? So one way to do that is that, hey, it'll be better for each one of you have their own bike, right? Instead of using the same bike. Using the same bikes requires that, yes, you have only one bike and then the other needs to wait when that bike is available, which makes it quite hard to manage. But if everyone have their own particular bike, there is no need to actually to wait for something. They can actually do what it's supposed to. Again, it requires resource, okay? So generating this new bike requires a lot of resource and hard work. And even though, well, each one of those, they can have their own bike. And let's say if they want to now have the new bike, the new, whatever hot new bike it is, they can sell that and purchase this new one. So the whole point of this, using this real life analogies in the context of now the digital world, which is more like an abstraction, it's pretty much the reason why we are dispatching is this new bit of a state. Again, perhaps my example might be not 100% accurate, but the relationship here is to see now how you can is look at these real life examples as well as the real life challenge, right, on the physical world, and then how you can apply that to the digital and see what are the series of steps, the algorithm, the techniques, and the data structure that you can do to actually come out with some sort of solution. Yes, that's what we want. That's something powerful, by the way. Yeah, that's something powerful. So yeah, cool, totally cool. Good. All right. So that's why we are here. We look at the slice, where now the slice actually create is a function that takes is the initial state, as you can see here. It's a function that takes is the initial state, the reducers, uh, and as well as the name that you can add to this slice, okay, that is going to generate is actions, actions type that's going to create actions, actions types, as well as the reducers in the new in the state out of this. So create, this is create slice redux. Let's gonna take a look at this. A function that has set an initial state, an object and reducer functions, and a slice name, right? And automatically generates is this actions creator, the actions types, and the corresponding state and the reducers. So there is a lot of ceremony that is doing behind the scenes. Steve Keeney actually makes us to say, hey, let's going to create now an action. Okay, let's going to create now is an action. As a way to understand what is how this create slice works behind the scenes. So we look at the create actions, and then we're gonna look at the create reducers, and let's get into this. Right? Let's get into this. I don't receive any. Oh, okay. Okay.
Diablo, loco. Sí, diablo. De débil. De débil, mano, de débil. Y no es el débil.
Oh yeah, yeah, yeah. Stand up, stand up, stand up for me. What? Stand up, stand up. Don't give up, you're fine. Alright, so because of that, here we are, right? We're gonna actually take a look at the example here, especially on the create actions, right? As a way to get a more hands approach on that, it's gonna stop this and then take a look at the performance here. Use read list here. Okay. Super tasker, that's right. Okay, this is as a way of how you can deal with these different models. All right. Yeah.
Awesome. All right. So
Create action exercise. You got it. So create actions exercise. But let me actually change my branch to the get switch here. Fatal. Get accident counter repo. Oh, I get it. Oh, but this is another repo. Okay. The accident counter repo. Okay, you got it. It's here. It's gonna clone this repo here. You right so you so you can see what I'm doing right now. No, it's not. No, it's not. Is this one? That's right. It's this one. All right, so let's go to actually change to this another repo, which is accident counter. I'm gonna open up here. All right, but again, I want this to change to that accidental counter here. This one, there you got it. So change here in the same. Okay, cool. Okay, okay. So lib and components. Okay, there you got it.
So to prove our point, let's go ahead and let's refactor this a little bit with.
And here we go is into get switch. Thanks for that command to access. There you got it. Now I'm now it's pulling a different reference on there. Exactly, we already got this, which is what I want to. Please remove the sidebar as well as the terminal. Wait, what? Okay. As well as the terminal. Okay. And here we are. That's right. So this is now how you can transform again, this is part of the migrations, how you can transform now a reducer functions to now make it work with Redux, right? So because of the, okay, let's get into this.
Awesome. All right, so to prove our point, let's go ahead and let's refactor this a little bit with the actions, and then we'll swap in the reducer as well. So what we can do here is, again, the createAction, and why not? I'll repeat it one more time, is great because you can use this anything you have right now.
So here we're gonna just create our actions, right? By saying, hey, I want to create an action here. What I'm going to put is now is the increment, okay, followed by the, I don't know what is not, oh, okay, I get it. No, I get it. No, it's okay. Yeah, I know why this is not working, because yeah, it doesn't have any dependency. So the server that is running behind the scenes when you are in a TypeScript file, which is the TS server in the TypeScript server here, right? The TypeScript language server, okay, which is something that is now running behind the scenes for ourselves. So VS Code actually is now running that, which means that when you take a look now at the TypeScript here, right, tackling TypeScript, the HTML version. What is the home page of this book? What is in this book? Exactly, programming TypeScript via an integrated developer environment. So, a couple of things. One important fact to be aware is that Visual Studio Code processes TypeScript source code in two independent ways: checking them or building. Right? So in this moment, again, yeah, Visual Studio Code and Web Store, they now process TypeScript source code in two independent ways. These integrated development environments provide that, right? So whether it's by checking an open file for errors or using building, which is compiling TypeScript files to JavaScript files. So this is the two way of how now this IDE process your TypeScript code. So one of them is by checking open file for errors, and this is done via language server, okay? An interesting and community-driven source of knowledge for language server protocol implementation. So you have one single server that can now provide to multiple clients. Even in Dino, what? And what about Ruby? A Ruby language server. That's very, very interesting. A Ruby language server. And TypeScript provide all of this. TypeScript language server. So, let me actually show this because I think this is quite relevant. It's not wild. Because I fed up. Jesus, I got an issue when I didn't receive any of these auto completion features, right? And it's because TypeScript, when you are using an ID with the TypeScript, it so the ID processes your TypeScript files in two ways. One of them is now they detect errors when you run a file, which is a great thing. That's right. And this is done via language server. So this language server, again, according to Ross Meyer book about tackling TypeScript, okay, he mentioned is that this is the two ways of how now Visual Studio Code process TypeScript files, whether it is by checking is and open files for errors via language server. A language server exists independently of particular editors and provide Visual Studio Code with language-related service, detecting errors, refactorings, auto-completion, etc. Right? Communication with server happens via a protocol that is based on JSON RCP. Okay, so RCP stands for Remote Procedural Calls. The independence provided by the protocols means that the server can read them. Exactly, the independence right by that protocols means that the servers can be reading in almost any programming language. So important fact to remember, the language server only lists error for currently open file and doesn't compile TypeScript. It only analyzes it static, which is why I get these things like, hey, why I don't receive this particularly helpful error? Okay. But that it is, right? It's because of this. This language server actually, this is a way of how TypeScript actually process these files when you're using an ID, right? So whether it's using a language server that is detecting errors at the file base, and it doesn't do that for all your TypeScript files, all right? And because it's now communicate to the server using the remote processor call, you can write your language in any language that you need. And the other is the building, right? Here there is another choice, and this is actually now is going to statically analyze all of your files in your code. Okay, whether it is in watch mode or what you're gonna do in one run. Okay, good. That's interesting. So this is what it's doing behind the scenes. That's right. And okay, let's get into this. Let's get into this. Okay, so here now we can create an actions here. Okay, that'll be is the increment. Okay, followed by the actions or the prepare actions here. So this prepare action is a utility function that creates an actions creator for a given type on a string, and this create actions here is a function, an action creator for a given type of action string. So you say it's like, hey, I can now is do something like this. Like say, hey, return is this type with the increment, right? Increment, okay, followed by the payload, right? Which is whatever you receive here as it is, right? Oh, come on, man. Which is whatever you receive here as it is. Make expensive, sleep. Okay, it doesn't tell me what actually is this create action receive. Prepare actions, okay. So you create actions, which is now this, all right. So you got now the type, okay, as well as the prepare action. So excited because you have to create is the type and the payload followed by the actions. Here with this action you say, hey, create actions counter increment. Okay, that's interesting. And he's going to generate that for
use anything that you have right now. So here we'll say that like an amount.
Okay, exactly. Functions, you can say prepare text, okay, that are going to receive some payload, that are going to receive some payload here, and in this case is which is an amount, okay, and the amount.
Third time's the charm in spelling it is a number. This is what I wrote before as well. And that will return a payload that is that amount. Cool.
Okay, so I don't need to. Okay. Mm-hmm.
If we grab that for decrement as well.
Yeah,
Keep that the same. Like,
action.
could you make an abstraction? Should you? No. And then finally, we'll do one more.
Decrement. Right. Which is amount. Which is a type of number.
And this one doesn't need anything. So we give it no function, it will automatically
return
hit this type correctly, right? This idea of a payload that doesn't match, right? Because it's defined as undefined. I might get yelled at. I'm pretty sure that I get away with if it is explicitly undefined, because that's how JavaScript object works.
As well as the another create actions here. Create actions. Okay, which is say, hey, let's go to create now a reset for that.
But this type that had nothing to do with this type is in like my hypothetical existing code base. I'm trying to like just have better tools, better abstractions, so that the next feature I work on is less tedious than the one before, so I can like impress my boss. If we have this in place, we should be able to then just say better tools, better abstractions, so that the next feature I work on is less tedious than the one before, so I can like impress my boss. If we have this in place, we should be able to then just say
Mm-hmm. But increment doesn't exist because you haven't assigned to any variable here.
It's why you live code in front of your friends.
For example, like this.
And then finally reset.
Increment.
And these are the action creators. These are ones if I call these functions later and I pass it a number, it will create the correct action. Right? And that will just kind of work for me. We can use it. We'll try to like bind it to dispatch as well if we really need to. But cool. So we'll have that in place, and now I can just swap these out. And I no longer have to do that entire ceremony, as I mentioned earlier, of making the action types, storing them in.
So now what we can do instead of doing this, since I get is this function that is in one place, you say now increment the type. Similar for this, you can now say, hey, decrement the type, okay, and similar for the reset. Say, hey, reset, right, the type. But as what happened here is that is automating is all of this things for us, right?
Storing them in constants and then making the action creators by hand, like that is just done for me. And as I alluded to earlier, right?
Because it's doing things to these
if I'm using TypeScript, if I try to do like, even as I hit the dot, you'll see payload is not an option on this one. But if I went up, like here, payload clearly works. I'm not getting a TypeScript error. Automatically typed, automatically ready to go. All the boilerplate gone through one simple function that worked with useReducer, works with vanilla Redux, right? So even if you only grab that piece of the like buffet and good to go, like awesome, like more productive, ready, rock and roll. So,
do these actions it's creating have like a success and a fail and all that stuff, or are we going to do that?
Though when we do the asynchronous ones, we will actually, yes, and these don't.
Okay.
These do not, right? Because these are just asynchronous, hey, this thing happened, right? But like all of the ceremony around thunks and promises resolving and pending and failing, there are also abstractions for that. And it's all wired up and ready to go in a way that you can use just like out of the box, right? And so we will see that, absolutely. These are just standard, like a thing happened. I'm just telling you, reduce or deal with it or don't deal with it as well. So we're going to have that in place too. And it, like I said, any of these pieces that you like, it's like for everything I'm showing you, you just take what you like. You take the little pieces that work for you and work in your code base. You take the free TypeScript support. You take the convenience, right? You leave what you don't want. It's totally cool with me. I won't feel bad about it. And so now we've eliminated a whole bunch of that kind of common complaining about React, which, to be clear, I have participated in the complaining, right? That is just taking care of it for us. Now, one thing that we can do, and this is a little bit of just a TypeScript like hack, which is like the like return types here, like of these functions theoretically we could use, right? So like we could take it and say like we want to get rid of this piece here. I'm just gonna move it down underneath. We could say either type of either one of these will work. Like that. If you look at this one, you'll see that it's now automatically got the correct type. Or you could do the return value of the function. You could do you can pull it out. If you wanted the actually, I would recommend actually this instead. But the other one will work if that's what you need.
Return value.
Type of return value.
Exactly. The return value, the type of increment.
Return type.
Is a utility function. Because you already have a question mark at the end.
Return type. Doing the function return of an argument. What's that question mark at the end? That was just me having a typo. There we go. Typo gone. And if you look at the counteraction, we will get the same union by just grabbing the return types of these created actions, and it will automatically as we add things. Now there are other ways you know, like if we use some of the slices, we'll get all this for free as well. But this is some of like how this is working on our behalf. In case you're like, I don't like magic. Well, I'm here to dispel the magic for you. And then we say return type of decrement. And then we could say like, for the same as like, could you write like a very fancy type that just took a list of them and did this? You absolutely could. Could you put them in an array? Yes, you can do a bunch of stuff. I'm just here to show you that you will get the full automatic type support for the counteraction, just like you manually wrote it before.
And this is not to provide, it's more TypeScript friendly support. So instead of actually you having to do this, all right, instead of you having to do this, all right, what you can say is like, hey, I want now is to do this. Give me the return value of the type of give me the return value type of the increment, okay, and as you can see here, gonna find return value is return type. Exactly. So you say, hey, this is one, the type and payload, all right. We can do the same for return now type of the type of decrement, all right, and say, hey, it can be this or another one. Now you're incrementing is this type here, and then return type, and then return type of reset for this function based on this create action, and say, hey, it can be increment, decrement, and reset. That's quite interesting. And all of these the possible actions that you can do, and you're gonna get is that now behind. Exactly, you're right. Actions creator for that.
Cool. Now you will get the same, like, only passing the arguments that work, so on and so forth. This is the same type that we had before. Payload undefined, number for the other two.
Okay.
Boom, done. All convenient. No guessing, no manually having to try to figure it out yourself. Based on the code that you defined, you've declaratively also set up all the types, right? And, you know, I will make this point once again because Phil brought it up, like, you get fun, at least autocomplete and helpful hover hints in VS Code if you're in JavaScript. So.
All right, so that'll be all for this video. Take care. Bye-bye.